I think it's about time to start. Well, hello everyone. I'm Wieger Opmeer, which is a very difficult to pronounce Dutch name for anybody who's not non-Dutch. As you can see from my email address, I work at Strato. Strato is a German hosting provider, one of the largest in Europe, by the way. And Strato has been around for a while, about 20 years by now, so that means that we had some problems. Problems like having too many departments, having too many systems that all need to talk to each other. We actually drew graphs of them at some point, and we ended up at a fully connected graph or mesh or something like that, almost fully connected. It was rather interesting. Worse even than having the fully connected mesh is that most of those protocols or all those systems talk different protocols. Lots of those protocols were homegrown, ad hoc, implemented, whatever. So there is SOAP, there's XML RPC, there's lots of other things. That makes talking to other departments rather awkward. It takes a lot of time to implement something new. Not very good situation. So where we want to end up, or we want to have a solution, and one step is to try to migrate to one protocol, and the next step would, and at the same time, try to introduce API aggregation points, or like the title of my talk, service composition. So what is service composition? Service composition basically means piecing together various microservices to form one bigger service, hopefully with a coherent API, but at least there's one point to talk to. That's the important bit. Of course, there's multiple ways to get there. In the REST API world, service discovery is a thing where you ask a well-known directory service where this particular service you want to talk to lives nowadays. That has its issues, as in the directory service needs to check if the services are still alive. How long can you, as a client wanting to talk to a service, rely on that information? Do you have to recheck that on every request? All that. It has its implications, but if I recall correctly, Twitter has a platform for that actually works quite well. Another approach, the more natural approach, is to do something man in the middle, or a proxy or something like that, or a... This better? This better? Something like this? Okay. Okay. Now that everybody can hear me, there's multiple ways to do this. The middleman approach is, or an API gateway is, the approach we took to try to solve things. So the title of my talk could also have been this. Of course, we went through a lot of names trying to find out what we were going to call our thing. API gateway is too generic, service switchboard was too long. At the end, we ended up at RPC-Switch. How does this work? Clients connect to the RPC-Switch and call methods, standard JSON-RPC. Workers connect to the RPC-Switch and announce methods, which is actually calling a method on the RPC-Switch called announce, and then you say, hey, I'm worker this and this, and I can do the MySQL size function that tells customers the size of their MySQL database, or things like that. An interesting fact of this thing is that a worker is a client, as in the protocol is basically the same. The only difference is that a worker has actually announced that it can do something. At the same time, a worker can also be a client on the same connection and consume other services. The RPC-Switch, or the middleman, rewrites and forwards requests after checking an ACL. So there's a configuration that tells which clients are allowed to call which services and all that. And there can also be something called request-based authentication, which means that for every request we can actually say this is the customer service control panel, but I'm now working on behalf of this one particular customer. And then you can at later layers check, is this actual customer allowed to delete this mailbox? No, it's not your mailbox. Not allowed. That's very useful for us to have, because then you actually can forward all kinds of trust information between the front end and the back end. If you don't have that, you at some point end up with system level trust things, and you need to trust that the front end has done all the checks. Our experience is that they usually miss some checks, and that then things go wrong. And in the reverse direction, if a worker has done something, the RPC-Switch just forwards the response. How we do that is something that we call two-way JSON-RPC over a netstring stream. If you can read the highlighted blob, a netstring is just a string on a TCP stream that is preceded by by a length byte in decimal, a colon, then the actual string of that length, and a comma. This means that once you've written the header, read the header, you actually know how much data is going to follow, and you can do that in one read. So you don't have to try to do a parse of the JSON structure to see if you're at the end or something like that. You know how much data there is going to be. JSON-RPC has some interesting properties. It's fully asynchronous. There can be multiple requests on the wire. Requests can overtake each other. And the way we've used it, both sides can actually send requests and responses, which means that for JSON-RPC, per request, you have a client and a server. That is per request basis. That is not on the connection basis or however that works. That is only on a per request basis, and we actually use that. The RPC-Switch does some rewriting of the request. Some simple things like mapping the namespace, so a method of one name can be rewritten to another one, which is useful if you have a worker announcing some method and you actually want to rename it or have it alias to some other method name to compose into a larger API. It adds authentication information so that the worker actually knows who's working for, and it adds something we call the virtual channel, which is basically a connection between the client and the worker. So a telephone connection or something like that. And that is important for routing the request back or the response back. Little example of the rewriting going on. At the top we see a very simple, very standard JSON-RPC request, JSON-RPC 2.0 request even. We call a method foo.add with some parameters. And then what gets forwarded to the worker is a method bar.add, and we have a extra field called the RPC-Switch field that has a who field, as in who is calling me, a customer, and the virtual channel information, which in this current implementation is rather readable, which is actually useful for debugging. We don't know if we're going to keep that, but this basically means that connection 1734 at process ID 12,098 is trying to talk to connection ID to add that other process ID. actually useful. When a worker has done something, the worker sends a response. The worker actually has to include the virtual channel information again, as in it needs to know which actual client it is working for. It needs to include that virtual channel information, and then sends that. Then the RPC-Switch will just send the notifications on that channel. Multiple responses are allowed because an extra response is just a notification in JSON-RPC terms. Simple example of a response. First response of the worker, standard JSON-RPC response frame with a result that says result wait, as in yes, I'm doing this, I'll call you back later, and I'll call you back with that string as the notification identifier. This is that I will have the response for you now. The second response then is actually a notification in JSON-RPC terms for the method RPC-Switch.result on a virtual channel, and the parameters, as in now we have a result OK, we have the same ID again, and we actually have the result, which is the add, and because this is the response of the request I show 2 sheets back, we now have a counter with the value of 15. Small implementation details. This is based on a Mojo IO loop server, handy little platform to write things in. Single process, some modules that we use to make things work. So we have a Mojo X NetSync stream, which turns a Mojo IO loop stream into a series of net strings that you can actually work on. Then we have a JSON-RPC two-way module that then gets the JSON chunk and does the JSON-RPC work with it. And we have a client library that a client or a worker can use to actually connect to the RPC-Switch. We also have clients in C, JavaScript, and Java. The C and Java ones are actually being used right now. The JavaScript one I don't know. As we speak right now, somebody should be writing the Python client, but I'll see that when I get back to the office. And what I want to do someday soon is write the Perl 6 version, just because that's interesting to do. And as you can see, it's about 1,500 lines of code, which for any size software project is actually rather small. So it's neat and small and works quite well. Nowadays we have a version 2, mostly because we actually wanted to distribute the work, the switching work across multiple processes. So now we have a multi-process system. So we have a master process, multiple child processes. We have a database with shared configuration information, as in the ACLs and things like that. Which for that we use LMDB file with temporary files. That works quite well. And then for communication between the several processes, we use something called PostGIS message queues, using the PostGIS RT MQ module. And that is a simple way of communicating between different processes. We could have used Unix domain sockets there as well. Maybe we will even switch to that at some point, but for now this works. So how does this, what are the pros and cons of the RPC-Switch? We have one well-known point to connect to, because people actually connect to the switch. It's an outgoing connection, which is with our firewall admins usually a lot easier to arrange than something incoming. In our world that works better. And we have one place for global configuration, like who's allowed to call whom, how are the methods called, etc. So there's also one global configuration that people can look in and see, hey, is there a method like this already available? One thing that I did not mention is that we actually have a little introspection thing built in where you can actually ask for information about the method, and if the worker can actually specify things like, okay, manual information, input parameter details, whatever. So you can all add that to your announce, and then people can actually ask for that. Works quite well. Cons, of course, currently one single point of failure. Now that we have a multi-process model, getting a multi-switch model going where multiple switches are connected via some intra-switch protocol should be doable. We have some ideas of how to do that, but we haven't gotten around to that. And instead of dependencies on admins and firewall administrators and all that, you now have a dependency on the RPC-Switch administrators to update that global configuration. For us, that is not such a big problem because we are the RPC-Switch administrators, so we actually took back some control. Works for us. Before I ask for questions, I do have another question, and that is, if anybody is looking for a job in Berlin, we're looking for colleagues. Okay, anybody have any questions? No? Yes? Why did we not use a message bus like RabbitMQ or something like that? We looked at that. We actually considered using RabbitMQ at some point, but this is so much simpler to administrate than having a RabbitMQ setup running. As in RabbitMQ, depending on how you can configure it, it can also lose lots of messages and you don't know what's happening. What we have here is so simple that you can read through the actual business logic in 5 minutes, and okay, any error should be obvious. More questions? No? Okay. Thank you for your attention.